Okay, good morning, folks. Welcome to snow day number 2 of this week. Excuse me. I'm just gonna not push things here too awful much. I'd just like to get to the end of Module 4 with you today. We're almost there. We're probably 9 or 10 slides away, so this shouldn't take too terribly long. And again, if you've got questions, kind of give you sort of two options. The first one, and the one that I'd actually really like to do, is if you just post them in the thread underneath this, where I post this video, this YouTube video. Just post questions if you want to have a discussion or clarify anything. I'm going to be here today, and other than doing a little snow blowing, I should be accessible. We were talking yesterday, and I'm going to back up a slide here just to kind of get you to where we were talking about. If you remember, we were talking about the nervous system, and we were specifically talking about how chemicals are ejected, called neurotransmitters, by the terminal buttons or the axon terminus of a neuron. Excuse me. And they're squirted into these little tiny gaps here. And when they do, those neurotransmitters fit in to these little receptors on the other side of the synapse from the next neuron, and typically either inhibit it so it won't fire or excite it so that it will fire, just depending upon the neurotransmitter, what its job is on the next neuron. And it fits in kind of like a lock and a key, and that's kind of where we ended off yesterday. And we just got to start talking about something called an agonist. Now, an agonist is a chemical that mimics a neurotransmitter. It looks very similar to it. There may be a couple of little things that are slightly different, but it fits well enough as a key into its lock to cause this second neuron, the second receptor area, to act as though it had received the actual neuron, so the actual neurotransmitter. And so we were talking yesterday, right toward the end of class, about things like morphine being an agonist to endorphin. Endorphin being something that we naturally produce in our body, and morphine something that we may, for whatever reason or another, need to take for pain relief or other symptoms. And when we do, it mimics, because it acts as an agonist, on the nerves by which we typically receive pain. An antagonist is another chemical that is not a neurotransmitter, but what it does is it goes in and it fits in, but not quite enough to cause the action that the original neurotransmitter would have called, but it actually plugs the hole, and so it prevents other chemicals from getting in and in fact causing the normal activity. Now, if this is, let's say, just plain, pure, and simply acetylcholine causing my finger to move, and acetylcholine is being squirted from one neuron to the next neuron, it would typically fit in. But if someone, let's say, had hit me with a dart of curare, curare is a poison that you can get off the backs of some South African frogs. You've probably seen it on television spoken of. And what occurs is that antagonist fits into the receiving areas, blocks it so that acetylcholine truly can't get there, and then the person is paralyzed. And so they're fully awake but completely unable to move. That would be an example of an antagonist. We're going to just talk a little bit about nervous system, and for those of you that have had Biology 12, you're going to kind of jump with glee because a lot of this is just review. But for those of you that are hearing it for the first time, I guess no one's going to get harmed by a little review. The nervous system is divided basically into two large chunks. The central nervous system, which is just the brain and the spine, sort of shown here in red, and then the peripheral nervous system, which is kind of shown here in yellow. And this is the part that feeds information to the central nervous system if you feel something, or if you're going to move, takes information out to the muscle or whatever's going to move the limb. So it's sort of the in and the out off of the spine. That would be our peripheral nervous system, kind of like how a mouse is a peripheral to a computer, and a monitor is a peripheral to a computer, whereas the computer itself would sort of be the central processing unit, and some of the main functioning boards, the motherboard perhaps, would actually be akin to the central nervous system. I don't think I have to read that out loud to you. The nervous system is basically all of the nerve cells, It's very speedy. So if you step on a tack or step on a nail, you get the information immediately. And in fact, that's what its intent is. Again, we've already discussed the CNS, central nervous system, and the peripheral nervous system. Nice little kind of diagram of the breakdown of the two. Again, we're breaking the nervous system into the two parts, the central and the peripheral. The peripheral nervous system can be broken into two parts as well. The somatic nerves are the ones that control voluntary movements of skeletal muscles. So if you're moving your fingers around, or you're doing something that requires dexterity, or you're running, the nerves that are bringing that information out are our somatic ones, and we're under direct control of them. The autonomic, don't confuse that with automatic, the autonomic ones, they're self-regulating, and you don't have direct control over them. Those are the sympathetic and the parasympathetic system. The sympathetic system is what we often refer to as the fight or flight. I'm sure you've heard that before. If you step out in front of a vehicle, you didn't know the vehicle was there, and it blasts its horn at you, and your heart jumps up into your throat, and your blood pressure goes up, and your eyes widen, you begin to sweat, and all the rest of it. That is direct response over the sympathetic nervous system. And it is designed to keep you alive. You can kind of think of it as it keeping sympathetic to keeping you alive. If you didn't get that big burst, then you wouldn't be able to move quickly out of the way if it were truly an emergency. The other end of that is the parasympathetic nerves, and these are nerves that in fact kind of work in the reverse of the sympathetic. They're designed so that once the situation has passed, you don't need to have a heart rate of 220 all the time, and you don't need to have your blood pressure well up over 180 over 150 or something horrible like that. The parasympathetic nerves, are designed to sort of calm you back down and bring you back to a state of homeostasis, of resting. How many different kinds of neurons are there? There's many different kinds of neurons. These are some of the major ones that we deal with. We'll start over here with the sensory neuron, where the dendrites pick up the information. So if I touch my finger, then this first neuron that receives that information, that would be a sensory neuron, which would be like this. The next series of neurons that would bring the information toward my central nervous system are interneurons, and they're just kind of like relaying it. If I decide that I need to move my finger out of the way, then that information would travel out of my spinal cord and down toward the muscle, here, let's say, or here, to cause my finger to move out of the situation. That's on a motor neuron. So a lot of people would say this is sort of direct input, this is direct output, and these connect everything to and from the central nervous system. And so interneurons are what we call unipolar, sensory neurons bipolar, motor neurons are multipolar. Okay. Somatic nervous system, the division of the peripheral nervous system that controls the body skeleton, and the autonomic is the part that controls our glands and our other muscles, which we are not in direct control of. Nerves, we talked about this yesterday, they're kind of like large cables that contain many neurons. They also contain other tissues as well, connective tissue. It's not just pure neurons, there's other materials in there. There's those myelin sheaths, those glial cells as we refer to them. And those are all part of the peripheral nervous system, because we don't find nerves, if you will, in the spine or in the brain as we do neurons. Nerves are typically those cables of neurons that we see in the PNS. Again, you can read that, sympathetic nervous system. It's the division of the autonomic nervous system that arouses you, gets you out of a stressful situation, hopefully. Parasympathetic nervous system, also part of the autonomic, does the reverse of that. Here are some very typical responses that we have of the sympathetic nervous system when you need to get pumped up to get out of dangerous way. When you see something that's highly distressful, let's say a bear charging at you out of the woods, that would be highly distressful. That's going to dilate your pupil. Your pupil's going to open. You're going to try and gather as much information as you can. If someone's excited, if someone is, let's say, lying to someone, then and their pupils may often dilate. So you may have seen, excuse me just a moment, folks. You may have seen or heard of people doing polygraph tests where they're looking at all kinds of these symbols of excitement. One of them would be to dilate the pupil. Another would be heart rate, where the heart rate is accelerated, again, to try and give you a burst of energy. The stomach stops digesting food. It diverts energy from digesting its food. It figures that it can do that later once the danger has passed. The liver is going to release sugars into the bloodstream for obvious reasons. You may need a blast of ATP. You may need that sugar to get out of this situation. Your kidneys have a small gland on the top of them called the adrenal glands. They're going to squirt out a tremendous amount of epinephrine and norepinephrine, which is going to cause your heart rate to rise. It's going to cause your arteries to constrict and your blood pressure to go up, again, to make you Superman for a brief period of time. It will relax your bladder. In fact, if the situation is really very startling, you may relieve your bladder. You've probably heard of that occurring. And it is also the same system that when highly excited causes ejaculation in men. It's not typically due to fear, it's obviously sexual arousal. Parasympathetic nerves do almost the reverse. Instead of dilating the pupil, it contracts it, brings it back into size. Rather than elevating the heart rate, it slows it. It actually resumes digestion. It actually stimulates the gallbladder to break down fats and to not release, the liver not to release sugars. The bladder comes back into control, it contracts it, allows it more under control, and it allows blood flow to the sex organs, typically to resume normal activity. When we look at the brain, it is a tremendous network of neurons, and what we have is this rather large interconnection of neurons in what we call a neural network. When we look at animals, and humans too, presumably, that have had rich life experiences, we discover that they have very complex neural networks. If you take, let's say, I'm just going to look at that slide is here. No, it's not. No, it's not. We'll see it a little later on, I think in another unit. Another module. If you look and you take, let's say, a rat, and the rat is placed in a very rich environment with wheels and things to climb on and different riddles and so on to solve to get food, maybe other rats in their cage by which they can commune with, and then we have another rat, let's say, that lives in a very relatively impoverished environment with nothing in the cage and no other outside contact. When the rat's brains are examined after a period of time, we discover the rat that lived in the more complicated environment has a more complex neural network. Throughout its life, it required greater knowledge, it required greater brain activity in order to get through its life, and therefore the neural activity and the neural networks are built more complex. Whereas the rat living in the more impoverished environment tends to have a more simplistic neural network without as many internal connections. I think we've all heard the term reflexes, and again, those of you who have already taken Biology 12 are probably cheering right now because you've seen this before. A reflex, we often think of, we talk about a goalie having fast reflexes or some sports figure having fast reflexes. Those are not reflexes. Those are learned behaviors that some people are very good at. A reflex is something that is totally involuntary because what it is, it's a basically way to help preserve the body. In this case, they're showing a finger over top of a candle, and if in fact this were to occurring and then the candle was very hot, the person stuck their finger in it, they would immediately and involuntarily jerk their finger away. They don't even need to have a brain to do that. If you can, to be morose, if the brain were completely removed, the head were removed from the body of a guillotine or something like that, for a period of time the person's physical reflexes still work. There really is no requirement for a brain with a reflex, and the reason is this. If you put your finger over top of the strong stimulus, in this case a flame, the signal travels up through the peripheral nerves, and as it does, it enters the spinal cord, and because it is so large a stimulus, and there are so many impulses coming so quickly from this heat source, that it actually roots right around in the spinal cord. It doesn't even have to go up to the brain, and then it swings back out straight to the muscle to say, get your finger out of there. So it's like a direct line, which actually requires no brain activity. Now, assuming the person's alive and everything's functioning well, then this reflex will act and the person will jerk their finger away involuntarily. If you've ever had the doctor tap your knee or your patella and your leg rather moves, they're looking at the reflexes to make sure that the nerves are healthy down there. But you also feel it, and that is because when the signal comes in, it doesn't also just loop around, it also sends a signal up to the brain. So if this person puts their finger over that candle, there's going to be two actions. Number one, it's going to come in and cause them to jerk their finger away immediately before more cellular damage can go on, rather than send the signal up to the brain, have the brain make a decision to move the finger, and then send the information back down through motor neural networks to move it. That can take a couple of extra critical seconds where damage would occur. So these reflexes are basically designed to keep us healthy. If something's very hot, very sharp, we'll pull our hand off of it or pull our leg or our foot off. If you've ever stepped on a nail in a board or something horrible like that, and you've jerked your leg up, and then of course after your leg's up and it's off the nail, now you've received the pain a moment or two later, so you may actually have your foot off the board and the nail ejected from the foot, and then all of a sudden, yow, you'll feel it. Because this has already come and made full circle before the impulses in fact made the brain. Another affect of our body on our psychology is the response of our endocrine glands. Now, when we spoke about nerves, we talked about how they were very quick and very fast. And so if you put your finger on something hot, the electrical impulse, the electrochemical impulse getting to your spine is very quick, relatively speaking. Your endocrine system, your hormone system, is rather a slow chemical communication system, but it is an ability to communicate. And if we go around, you'll see that we've listed the major endocrine glands here: the hypothalamus, the thyroid in the throat, the adrenal glands over the kidneys, which you've discussed, the testes in males, ovaries in females, pancreas in both sexes, parathyroids, and the pituitary gland. We'll talk about those here. Hormones are chemicals that are literally ejected into the body, into the bloodstream, typically by these organs, and then they have an effect elsewhere. So the ovary may release chemicals into the bloodstream, which may have an effect on the brain, or may have an effect on the uterus nearby. But we're going to see that it's a chemical messenger, and it's not quick. It may in fact be out there, and it has a resilience. It's not sort of just a one shot. It may the effect of the emission from any of these endocrine glands may last for weeks or even a lifetime, depending. And so, for example, of a hormone, adrenaline or epinephrine, increases our heart rate, our blood pressure, our blood sugar, and feelings of excitement during an emergency. This one is in fact designed to be felt for a fairly brief period of time. We'll talk a little bit about this. The gland that's in charge of all of those other glands that we discussed, the ones up and down the body, is the pituitary. We often refer to it as the master gland. And the pituitary can release a whole variety of different hormones. And what they do is they typically have affect in various parts of the body. In some cases, they affect the whole body. But the pituitary often is sort of standing in control over many of the other glands, telling them when to and when not to turn on and off. Our thyroid gland in our throat is this large sort of butterfly-shaped thing, and in the middle are these little red dots. Those are the parathyroids. The thyroid gland tells us how fast we need to burn our sugars. It doesn't regulate sugars as much as telling us how quickly to burn it, what you and I would refer to as our metabolism. So someone who has a high secretion of thyroid all the time would be burning lots of sugars, and in fact, if in fact it's a problem, can become a real issue where we may have to remove some thyroid tissue. More commonly, however, we have hypothyroidism, where we have a drop in the amount of thyroxine, which is the hormone released by the thyroid, and in fact metabolism slows and the person may in fact be very sluggish and have difficulty. This can affect someone's psychology. If the brain isn't functioning well, that it's not consuming sugars and therefore not generating enough ATP, it can affect mood, no question about it. Parathyroids are embedded in the thyroid, and they help regulate the amount of calcium in the blood and therefore bone deterioration and bone growth. Our adrenal glands we talked about earlier, sitting over top of our kidneys, these release adrenaline or epinephrine, which is designed to get us out of a sticky situation in an emergency situation. Our pancreas does a number of things. It makes all kinds of chemicals, many used for digestion, but it also does act as an endocrine gland by releasing insulin. And of course, by releasing insulin, that tells the body how quick to take sugars in. And then, of course, thyroxine, how quickly to metabolize them or burn them. And if someone is, let's say, has too much insulin in the bloodstream or too little insulin in the bloodstream, that can also affect the brain and therefore the psychology of the individual. Gonads, male and female, they regulate reproductive organs. They may also help regulate sex drive. They also regulate fertility. And so clearly, if they are over-secreting or under-secreting, that too can affect the psychology of the person. You've probably heard of someone injecting a variant of testosterone for performance-enhancing drugs, and therefore, and afterwards having difficulty controlling emotion, what we would in the vernacular talk about roid rage, and being having difficulty managing their emotions, and with ovaries, some women experiencing difficulty if they're taking like a hormone replacement therapy, or if they're going through their regular monthly cycles, they may find that at some point in their monthly cycle that they're having difficulty emotionally or not. Some have difficulties, other people have no difficulties whatsoever. Okay, and so that's the very basics to end our Module 4, and we will talk again. If you've got questions, put them in the thread underneath. If you have no questions, or if you want to write them down and ask them in class tomorrow, by all means do so. Enjoy your day. See you tomorrow.